In this video, we're going to talk about compound interest. In the previous video, we talked about simple interest. So if you're looking for a video on simple interest, I'll pop the link up here at the top. But compound interest is a little bit more complicated, but it's how mortgage payments are calculated, for example. Anytime there's a growth rate, if they want to estimate the population growth rate of some country, they use something similar to compound interest. And in fact, outside of finance, you can also use it to help us study the spread of a virus in a pandemic, which we're living through, or dating fossils uses some of this math as well. But we're going to all stick to financial examples here. So the variables are pretty similar to what we did with simple interest, but we do have a new one here. We have this variable n that shows up here in the exponent and here in the denominator of that fraction. This is the number of times compounded per year. So a very common example is your house payment is due every month. So that means your mortgage compounds monthly. So n is how many times in a year is monthly. So we would say that's 12 because that's 12 times in 1 year for a month. So if it's daily, n is 365. If it was some other number like semi-annually, you would say n is 2. So if say you're the bank, the more often you compound, the sooner you get your money. It's like you're holding your hand out and saying, hey, I want my money today. I want my money today. So I could ask you for your house payment every day instead of every month, and I do get a little bit more money this way, but only because I get it sooner, because I don't wait until the end of the month to ask you for the money. I ask you for it every day. But by doing this, I'm not giving that money much time to grow. And so what happens here is if we try to compound as often as we possibly can, say down to the nanosecond, we get to this formula called continuous compounding. Because as n gets very high, the number of times you compound, it makes this fraction very small, right? It makes this almost 1. And it makes that number very big. So you have two things working against each other, and it converts to this letter e. And e is a special number that's a button on your calculator. It's kind of like pi in that it has this strange definition to it, kind of like pi is the circumference divided by the diameter of a circle. E is this number where we let n get really large here, and this wants to make it go to 0, this wants to make it go to infinity, and they fight against each other, and they result in this number 2.718. As our approximation of it. So we're going to come down and work this problem here. So for our formula, we have our principal, which goes here. That's the principal right there, 6,000. Our rate is going to go right here. We're going to write that as a decimal. So we're going to make that into a decimal. Make a little note there of that. And then compounded monthly. This is what we were speaking of earlier. So monthly means 12 times in 1 year. So we're going to put that in two places here. And then we're going to also put it down here. And then the time here is 4 years. So that goes right there. So let's plug these numbers in. So if we put all this in the calculator, we see that we get 6,000 parentheses 1 plus 0.055 divided by 12 and raise that to the 12 times 4. Now the tricky thing here is if you have, say, just a scientific calculator, not a graphing calculator like this one, you're going to want to raise that and you'll want to use either parentheses after you use the caret symbol, or you just want to go ahead and multiply in your head that 12 times 4 is 48. Otherwise, you'll get some errors when you do your math. So we press that in, and we get that the amount is 7472.70. And then for part B here, it says find the interest earned. So the interest earned would be very simply just like it was with our simple interest calculation. 7472.70 minus the $6,000 of initial investment, which hopefully you can see without a calculator is 1472.70. All right, and so that's a very basic example of compound interest.